Hey guys, welcome back to the show. Thanks for joining me. Today I'm going to be reading the fourth essay I've written, which is titled The Case for On-Device Compute, Speed, Privacy and Power. This is a series of essays that I'm writing to help shape my thinking. It gets me to think about it on a deeper level, share some of the thoughts I'm having, and expanding upon that, I guess, as we progress. So this is a way for me to explore these ideas, particularly as a builder in this space. And I think it's quite important that we think carefully about how, where AI is heading and what our responsibilities are, and how we can shape a positive future that we all want. And just on that point, guys, before I dive into the essay, I think sometimes maybe these topics get quite heavy, get quite dystopian, and maybe even a little bit negative. But I just want to stress that I'm an incredibly positive and optimistic person about the future. I think we're living through a hugely incredible moment in time. And although some of these thinkings can be quite heavy, I think it's important to do so, but with a lens of, from my perspective, certainly, I do have a positive outlook. I do think there's a positive future to be had. But I don't think we should shy away from the challenges and the dangers ahead as well. So this essay, like the others that I've written and read out on YouTube, I'm reading the verbatim, literally word for word. So yeah, I'm going to be this is a long one. So get your cup of tea, coffee, get yourself comfortable for sure. And I've got my glass of water. I'm probably going to have to take little breaks at certain chapters just to give myself a breathing space, because it is a long one and I'm going to try and do my best to do it all in one take, which is a challenge. It's definitely harder than it appears. So let's dive straight into it. But before I do, if you appreciate what I'm doing and get any value from it, please do subscribe. Really, really appreciate it. Will mean the world to me. And I thank you for everyone who has subscribed to date. And also let us know what you think in the comments. It's great to engage with you and hear your thoughts. So I really, really appreciate it. And I appreciate everyone who's, following us on this journey as we're, building what we're building with Whisper and the Nano Collective and everything else. So yeah, really appreciate everything. So let's dive straight into it. Enough waffling. Also, one last thing, just want to say, hope you had a Merry Christmas. I was hoping to do this video Christmas day before Christmas Eve. You know what Christmas is like. It all goes haywire, busy. I'm sure hopefully you had a lovely Christmas. And yeah, let's dive into it. Right. So the case for on-device compute, speed, privacy and power. As normal, I've got a summary for those who are reading on the Substack, key points and things like that. But let's just dive straight into chapter 1. Right. Okay. Chapter 1. The cloud era is ending. A philosophical and structural breakdown. There's a moment that happens in every technological cycle where the dominant paradigm still looks strong on the surface, but its foundation has already begun to crack. The cloud is in that moment right now. It still runs virtually everything, our apps, our communication systems, our AI models, yet the world is beginning to notice its underlying contradictions. For years, the cloud was sold as destiny. Everything will move to the cloud. It was repeated so often and with such confidence that it became more than a prediction. It became an ideology, a belief system, something unquestioned, unexamined, and, in hindsight, surprisingly fragile. But the cloud wasn't a philosophical triumph. It wasn't even an intentional design choice. It was a practical convenience that happened to align perfectly with the business models of the companies that controlled it. Centralizing compute eliminated the need for users to buy powerful hardware. It streamlined updates, it made product iteration easier, and crucially, it created an environment where personal data could be gathered, analyzed, processed, and monetized at scale. The cloud didn't win because it was the best solution. It won because it was the most profitable. And so, for a decade, the world drifted towards a single point of gravity. Your digital life moves outwards into servers you don't own, controlled by companies you don't see, governed by rules you didn't write. This was the quiet trade embedded into every cloud service. You get convenience, you get power, you get intelligence, and in return, you give up control, slowly, silently, almost unknowingly. You give up the ability to audit. You give up the ability to understand, to know what happens to your data, to run systems independently, and you give up the structural sovereignty of your digital life. And for a while, that felt acceptable, reasonable, even logical. But the bigger AI becomes, the more it integrates into cognition, emotion, identity, work, and the structure of society, the more impossible it is to accept this trait. Because AI is not search. AI is not social media. AI is not productivity software. AI is cognitive infrastructure. And you cannot outsource cognitive infrastructure without also outsourcing agency. This is the part that the cloud model cannot reconcile. The deeper AI integrates into the human experience, the more dangerous it becomes to centralize it. Not because the companies are evil, but because no institution, corporate or governmental, should ever control something so fundamental. This is the philosophical break. The cloud is convenient. The cloud is powerful. The cloud is efficient. But the cloud is structurally misaligned with a future where humans want autonomy. And that is why the shift towards on-device compute isn't just technological, it's ideological. It signals the beginning of a reversal in the flow of power. For 20 years, data flowed outward. Now, intelligence begins to flow back inward. The individual becomes the new center of gravity. Not the server, not the platform, not the infrastructure provider, the person. This is the turning point we're living through, and it's only the beginning. Chapter 2. The Edge Reawakens. The Return of Local Compute. If you zoom out far enough, the history of computing follows a rhyme. A pendulum swinging between centralization and decentralization, between shared infrastructure and personal ownership. We began with mainframes, giant machines in cold rooms run by specialists, accessed by terminals with no intelligence of their own. Then the pendulum swung, personal computers arrived, and suddenly the individual became powerful again. You didn't need a mainframe. You didn't need permission. You could create, think, code, build autonomously. Then came the internet and the cloud, and the pendulum swung back once more. We traded local strength for network convenience. Instead of running software ourselves, we logged into platforms. Instead of files, we had accounts. Instead of ownership, we had terms of service. Everything drifted outward again. And now the pendulum is swinging back. Not because decentralization is trendy, not because people suddenly care about privacy, not because local compute is nostalgic. It's swinging back because the hardware has finally caught up with the ambition of local-first intelligence. Every modern smartphone is a supercomputer by early 2000 standards. The neural engine in an iPhone, the hexagon DSP in a Qualcomm chip, the AI acceleration inside Apple Silicon, these are machines built for the kind of inference that once required a lab, a cluster, or a supercomputer. The idea that you must send your data to a server to process it is no longer technically justified. It's simply historically habitual. And as soon as people realize the habit is optional, it becomes untenable. We're rediscovering something obvious. Computation is more powerful when it lives where the user lives. It always was. The cloud wasn't superior, just early. Edge compute is not a step back, it's a return to equilibrium. Chapter 3. The Physics of Locality. Speed as a law, not a feature. Most discussions about on-device compute focus on privacy. That's important, but the more primal benefit, the one that changes the feel of intelligence itself, is speed. Nothing is faster than not needing the network. Speed is not a UX perk. Speed is not a convenience. Speed is a law of physics. Every packet that travels to the cloud must cross physical space. Every request must traverse switches, routers, fiber, backbones. Every response must return along that same path. Every layer adds delay. No matter how advanced the model or how optimized the platform, you cannot beat the speed of not traveling anywhere at all. Local inference collapses that distance to zero. You ask a question, the compute happens immediately. You type a message, the model responds before your thought finishes forming. You speak, the AI interprets you in real time with no bounce to a data center. This transforms the relationship between human and machine, because humans think in near real time. When AI delays even slightly, you fill the gap. It interprets the cognitive loop. But when the latency disappears, AI stops feeling like a tool and starts feeling like an extension of your mind. It becomes reflexive, almost instinctive. Cloud AI can play chess with you. On-device AI can think with you. The difference is small on paper and enormous in practice. Speed isn't just about performance, it's about intimacy. The sense that intelligence is present with you, not far away behind a wall of infrastructure. And the more AI integrates with our thoughts, workflows, emotions, and identities, the more that sense of immediacy becomes essential. On-device compute gives AI a feeling of presence that the cloud can never replicate. Chapter 4. Privacy, the last non-renewable resource. Privacy is often framed as a political issue or a legal issue or a moral issue, but privacy is something far more fundamental. Privacy is a psychological necessity. Humans need private space to think, reflect, imagine, speak freely, and explore ideas without fear of judgment or surveillance. Historically, that private space lived in our homes, our journals, our unspoken thoughts. But AI changes that terrain. We are not giving AI our search queries. We are giving it our inner life, our anxieties, our desires, our doubts, our emotional patterns, our unfiltered minds. AI is not a tool we operate. It's becoming a companion we confide in. And that makes cloud-based AI uniquely dangerous, even if the companies behind it have good intentions. Because when you speak with a cloud AI, you're not just interacting with a machine, you're interacting with a logging system, an analytics pipeline, a training corpus, an identity graph, a behavioral model, a potential surveillance vector, a long-term dataset about who you are. The data we give AI is more sensitive than anything we've ever given to a digital system before. And the problem is not that companies are evil, it's that once data leaves your device, you cannot control it anymore. You can't audit what happens next. You can't know how it's stored. You can't know who accesses it. You can't know who models it. You can't know which models it trains. And you can't know if it's merged with your identity. And you can't know if it will be used in the future. This is why privacy is no longer a nice to have, it's a foundational. And this is where on-device compute isn't just technologically superior, it's morally essential. When inference happens locally, your thoughts stay on your device. Nothing is uploaded, nothing is logged, nothing is shared, nothing is sent to a data center. Nobody can subpoena it, nobody can monetize it, nobody can analyze it, nobody can weaponize it. On-device compute protects the last corner of human interiority we have left, because once your mind becomes a data source, there is no going back. Chapter 5. Power, infrastructure and control. If there is one truth that repeats across history, it's this. The entity that controls the infrastructure ultimately controls the society built on top of it. This has always been the case. The nation that controlled the sea routes controlled trade. The empire that controlled the roads controlled commerce. The state that controlled the newspapers controlled the narrative. The company that controlled the operating system controlled the software ecosystem. The corporation that controlled the social graph controlled the attention economy. Infrastructure is rarely visible, but is always powerful. What most people misunderstand about AI is that the model, the software, is not the true source of power. Software can be copied, open-sourced, forked, reproduced. The model is not the moat. The infrastructure running the model is the moat. And today, that infrastructure is almost entirely owned by a handful of entities. Hyperscale cloud providers, large technology companies, state-backed cloud infrastructure, institutions with access to capital at nation-state scale. These organizations don't merely influence how AI is used. They dictate who can build, who can deploy, who can scale, and who can innovate. But intentionally, not maliciously, but structurally. The cloud creates a gravitational pull that centralizes intelligence, not because centralization is good, but because it is profitable and capital efficient. And over time, capital efficiency becomes political power. When AI inference lives in the cloud, the provider sees the traffic patterns, the provider controls uptime, imposes limits, sets prices, holds logs, stores embeddings, implements moderation, and the provider responds to government requests. The provider decides what is allowed and what is not. This is not theoretical. This is how it works today. Every developer building on cloud AI is building inside someone else's jurisdiction, technical, political, and economic. And as AI evolves from a tool into a cognitive infrastructure, this concentration of control becomes not just undesirable, but existentially dangerous. Because cognitive infrastructure underpins education, creativity, communication, emotional exploration, decision-making, personal development, political discourse, economic productivity. When all of that runs through a handful of centralized choke points, society becomes brittle, and brittleness invites abuse. Not necessarily by today's leaders, but inevitably by future power structures. Even well-intentioned institutions eventually face pressure to censor, to comply, to surveil, to monetize, to secure, to align with government directives, to restrict certain capabilities. This isn't paranoia, it's how systems behave when incentives converge on control. And here's the crucial point. The cloud isn't dangerous because the people running it are bad. The cloud is dangerous because the structure of centralization always leads to capture. You don't need conspiracies when you have incentives. The risk is not that cloud providers want to dominate human intelligence. The risk is that the architecture makes it impossible for them not to. If your product runs on their servers, you depend on them. If your intelligence runs on their GPUs, you depend on them. If your user data flows through their logs, you depend on them. Dependency is the raw material of power. And this is why on-device compute is such a profound shift. When intelligence runs locally, the infrastructure belongs to the individual. The inference layer is unobservable. The data never enters an institutional perimeter. The model cannot be shut down remotely. The user retains structural autonomy. On-device compute removes the hidden power dynamics. It dissolves the choke points. It decentralizes the control. It returns agency to where it belongs. But, and this is where honesty matters, on-device compute alone cannot fully solve the power problem. Some workloads will always require more compute than a phone or a laptop can provide. Frontier models will always push the limits of hardware. Coordination, resilience, and redundancy will always require shared systems. And this is why the future will not be purely local, just as it cannot be purely cloud. The architecture of the next era requires local intelligence for autonomy, encrypted cloud for scale, distributed compute for resilience. Each layer balances the others. Each layer prevents over-centralization. Each layer reinforces sovereignty. What matters is not eliminating the cloud, but removing the cloud as the single point of control. What matters is not glorifying on-device compute, but ensuring no institution owns the cognitive infrastructure of humanity. We've seen what happens when a handful of companies own communication. We cannot afford to repeat that mistake with intelligence. Because communication shapes societies, but intelligence shapes minds. And whoever controls the infrastructure controls both. Just have a quick breather. Right, chapter 6. The limits of on-device compute. If the story ended here, with on-device compute restoring privacy, autonomy, and speed, it would feel perfect. Too perfect. Almost mythological. But the truth, as always, is more complicated. And if we're going to argue for a more sovereign future, we must be honest about the boundaries of what on-device compute can do today and what it may never do alone. Because while on-device intelligence is a powerful foundation, it's not a panacea. It cannot replace every dimension of modern compute, nor should it try to. Reality is full of rough edges, and this chapter is about meeting them head on. 1. Hardware constraints are real. Yes, your phone is now a supercomputer by early 2000 standards, but even the most capable chipsets are limited by the laws of physics, not just engineering. On-device compute is constrained by memory capacity, bandwidth ceilings, thermal throttling, battery limits, storage constraints. And this means you can't run trillion parameter models locally. You can't train frontier models locally. You can't do long context, high bandwidth inference indefinitely. You can't exceed your device's RAM when loading models. On-device compute is powerful, incredibly powerful, but it is not infinite. And pretending it is infinite would be intellectually dishonest. 2. Frontier models still require frontier hardware. There's no way around this. Training the next generation of foundation models requires thousands of GPUs, months of compute, petabytes of data movement, distributed training frameworks, specialized networking, enormous capital expenditure. This is not something a laptop or smartphone will ever do. This is not something a decentralized network can do today. This is not something on-device compute can replace. Even inference at the cutting edge, full precision, high context, multi-model, world model architectures requires hardware that lives firmly in data centers. On-device compute can run excellent models. Data centers will run frontier models. This is simply the gradient of hardware. The mistake would be believing that the cloud must therefore be permanent and centralized forever. But the other mistake is pretending local compute can do everything. The truth is a third path, and we'll get there soon. 3. Coordination and redundancy still need shared systems. On-device compute is local by definition, but society is not. Humans exist in networks, social networks, economic networks, communication networks, political networks. If every AI system were purely local, collaboration would break, shared knowledge wouldn't propagate, resilience would collapse. There would be no collective memory. Global systems couldn't coordinate. Many tasks would be duplicated inefficiently. Some workloads must live beyond the edge. Financial coordination, governance mechanisms, global optimization problems, real-time multi-agent systems, scientific research, long-horizon training loops. Local compute gives autonomy, shared compute gives coherence, and we need both. 4. Safety, monitoring, and evaluation are harder locally. This is an uncomfortable reality, but we need to say it anyway. When inference happens on device, there is no central log, there is no central safety monitor, there is no unified dataset for model evaluation, there is no visibility into harmful outputs. This is a feature for privacy, but a challenge for safety. Cloud AI's greatest risk is centralization of control. On-device AI's greatest risk is decentralization of responsibility. We must design systems that protect autonomy without creating chaos or runaway misuse. This is solvable, but it requires careful architectural thinking. Ironically, this is also why distributed compute becomes necessary, not for surveillance, but for collective governance. More on that in the next chapters. 5. Updates and improvements are more complex. When models live on device, updates take space. Updates consume bandwidth. Backward compatibility matters, use of storage becomes a critical factor, fragmentation increases, distributing safety patches becomes harder. Cloud AI has a simple advantage. You update the model once, everyone benefits instantly. On-device AI requires delta updates, patching strategies, compression frameworks, compatibility guarantees, thoughtful UX around model lifecycles. This is not unsurmountable. Operating systems solved this decades ago, but it's not trivial. 6. Ecosystem fragmentation is inevitable. Every user has a different device, OS version, chipset, amount of RAM, thermal envelope, storage configuration, which means the model you can run is not the model I can run. The context window I can support is not the one you can support. The inference speed I achieve is not the one you achieve. Cloud AI gives uniformity. On-device AI gives individuality. A sovereign future must embrace individuality without collapsing into chaos. That requires architectural layers beyond just local compute. Chapter 7. The cloud isn't evil, just misaligned. If there's one trap the sovereignty movement must avoid, it's the temptation to treat the cloud as a villain, as if the people running it are scheming to centralize power, extract data, or monitor humanity from an ivory tower of GPUs. That's not how this happened. The cloud didn't emerge because someone wanted control. The cloud emerged because it was the most practical, efficient, scalable way to build the internet era. To understand where we're going next, we have to be honest about how we got here and why the cloud wasn't a conspiracy, but a technical inevitability of its time. 1. The cloud solved real problems. We forget how chaotic computing was before the cloud matured. Businesses had physical servers, unpredictable uptime, underutilized hardware, expensive maintenance contracts, high failure rates, massive inefficiencies, no ability to scale on demand. If you wanted to build a new product, you needed a server room, a network engineer, redundancy, failover, rack space, cooling, monitoring. It was prohibitive financially, operationally, and creatively. The cloud changed that almost overnight. It offered elastic scaling, global accessibility, near-instant deployment, managed updates, automated security patches, distributed redundancy, predictable pricing, extraordinary uptime. For developers, the cloud wasn't some sinister shift. It was a liberation. It removed barriers. It accelerated innovation. It unlocked an explosion of new applications. Modern software would be unrecognizable without it. 2. The cloud is not malicious. It's incentivized. When critics describe the cloud as bad, they miss the point. The cloud is not bad. The cloud is misaligned. Centralization creates economic incentives that inevitably warp the system, even if no one intends harm. Consider the incentives of cloud AI providers. They are financially incentivized to store data. They are incentivized to analyze usage patterns. They are incentivized to centralize intelligence. They are incentivized to retain logs for debugging, to create dependency loops. They are incentivized to integrate everything into their ecosystem, and they are incentivized to monetize the flow of data. This isn't evil, this is business. But the moment AI enters the picture, AI that shapes cognition, behavior, emotion, these economic incentives become societal risks. What's dangerous isn't intent. What's dangerous is structure. Power doesn't require bad actors. It requires concentration. And cloud AI has concentrated more power than any digital system before it. 3. The cloud is still necessary in many domains. No matter how far on-device compute advances, there are domains where the cloud remains not only useful, but indispensable. Frontier model training, large-scale inference, global collaboration systems, public datasets, resilient distributed storage, enterprise applications needing central control, scientific workloads, real-time multiplayer systems, massive multimodal processing. The cloud's engineering strengths remain enormous. It is scale efficient. It is cost efficient for heavy workloads. It is easy to maintain. It ensures consistent performance across devices. It distributes updates instantly. It provides redundancy and failover. It can coordinate billions of requests. The cloud is not going away. It shouldn't go away. What needs to go away is monopoly, the idea that intelligence can only live on corporate servers. 4. Centralization was a product of its time. The cloud wasn't a philosophy. It was a workaround. In the 2010s, edge devices weren't powerful. Storage was expensive. Mobile CPUs were slow. Connectivity was improving rapidly. Enterprises needed consistency. Economies of scale were irresistible. Centralization wasn't ideological. It was convenient. But technology has moved on. The world has changed. User expectations have shifted. Security threats have evolved. AI workloads have become deeply personal, and hardware has far outpaced the assumptions of the cloud era. We are now in a world where your device can run quantized LLMs. Your phone can perform real-time inference. Your laptop can handle transformer models. Your hardware has a dedicated AI accelerator. Your personal compute is underused. Your privacy is under pressure. The cloud is no longer destiny. It's just a legacy architecture with enormous advantages and enormous risks. 5. The cloud's real problem is not privacy, it's capture. The cloud's biggest flaw is not that it processes your data. The cloud's biggest flaw is that power accumulates where compute accumulates. Whoever owns the cloud infrastructure owns the logs, the bandwidth, the traffic patterns, the inference pipeline, the training data flow, the moderation layer, the failure points, the identity graph, the geopolitical leverage. This is not about morality or trust. This is about structural inevitability. If intelligence is centralized, power must be centralized. If intelligence is decentralized, power must be distributed. This is why sovereignty in AI is not ideological, it is architectural. 6. Acknowledging the cloud's strengths makes your argument stronger. Many people advocating on-device compute make a mistake. They attack the cloud as if it were worthless. This is not only true, it is strategically foolish. If you want the world to embrace sovereignty, you must show honesty that the cloud was necessary, the cloud remains powerful, the cloud has real advantages, the cloud is not going away. Because when you acknowledge the cloud's strengths, your critique stops sounding like rebellion and starts sounding like wisdom. It becomes clear that you're not proposing a revolution against the cloud, but an evolution beyond its limitations. Sovereignty is not anti-cloud, it is post-cloud. 7. So what's the real issue? Alignment? The cloud is not misaligned because of bad intent. It is misaligned because users want autonomy. AI requires trustless environments. Data is becoming more personal. Institutions are becoming more powerful. Societies are becoming more polarized. Compute is becoming more political. Intelligence is becoming a public good. The clouds cannot carry this future alone. It was never designed to. The next chapter explains where things go from here and why the answer is not a rejection of the cloud, but a transformation of the architecture surrounding it. Chapter 8. Let's just have a quick glass of water. Okay. Chapter 8. Why the future requires distributed compute. If on-device compute restores personal autonomy and the cloud provides scale, then distributed compute provides something deeper, something neither layer can offer alone. Resilience, neutrality, anti-fragility, collective ownership, institutional independence. Distributed compute is not a buzzword. It is not a marketing trend. It is not a crypto-flavored cloud. It is the architectural missing piece that prevents AI from being captured by any single actor, corporate, governmental, or otherwise. And if AI is going to become the cognitive substrate of society, that independence becomes a matter of survival. To understand why, we have to look at the problem through 3 lenses: power, scale, and trustlessness. 1. Personal autonomy. Alone is not enough. On-device compute solves the intimate personal layer of sovereignty. Private inference, local memory, zero data exposure, instant responsiveness. But when we zoom out, society needs more than private intelligence. It needs shared knowledge, cross-device continuity, collaboration, redundancy, large-scale processing, public digital infrastructure. If every AI system existed only on individual devices, we would lose the ability to coordinate, research collectively, train shared models, build global datasets, run safety evaluations, maintain public goods, recover from failures. On-device compute protects the individual. Distributed compute protects the civilization. 2. Centralized cloud cannot be the collective layer. Many people assume the cloud already is the shared layer, but that's only true if you believe that shared infrastructure must also be centralized infrastructure. The cloud provides scale, yes, but it also provides single points of failure, single points of political pressure, of corporate policy, of censorship, of economic control, of algorithmic influence. The shared layer of intelligence cannot be owned. It must be operated, it must be stewarded, it must be governed transparently, it must remain neutral. The cloud cannot offer neutrality because it answers to shareholders, regulators, governments, economic incentives, proprietary strategies, geopolitical pressures. None of these are inherently bad, but they are all inherently misaligned with the idea of shared public intelligence. 3. Distributed compute is the only architecture that cannot be captured. Capture happens through ownership, influence, economic leverage, legal jurisdiction, access to data, dependency loops. In any centralized system, these vectors exist, even if the operators don't intend it. Distributed systems dissolve these vectors structurally. A distributed compute network has no single choke point, has no single policy layer, has no single storage location, has no single organization in control, has no single set of incentives, lives across jurisdictions, cannot be coerced in one move, cannot be bought, cannot be monopolized. This is not ideology, this is engineering. If the infrastructure of intelligence is to remain open, safe, and sovereign, its foundation must be structurally resilient to capture. Distributed compute is the only model we know that provides that resistance. 4. Distributed compute solves the gaps identified in previous chapters 6 and 7. Each limitation of purely on-device systems finds its solution in the distributed layer. Hardware constraints, distributed compute provides pooled resources. No redundancy, distributed compute provides fault tolerance. No large-scale inference, distributed compute provides collective acceleration. No centralized evaluation, distributed compute provides decentralized verification. Model updates are hard. Distributed networks distribute updates peer-to-peer. Fragmentation. Distributed compute harmonizes global coordination. The individual becomes autonomous through local compute. Society becomes resilient through distributed compute. 5. Distributed compute is not about trust, it's about removing trust. Trust is not scalable. Trust is not enforceable. Trust is not sustainable across nations or decades or political cycles. Distributed systems solve this by replacing trust with verifiability, transparency, open governance, shared incentives, auditable operations, decentralized consensus. The goal is not to trust the network, but to build a network that does not require trust. This is what decentralization means when done correctly. It is not chaos. It is not anarchy. It is structured independence. And importantly, distributed compute does not replace the cloud. It balances it. It checks it. It keeps it honest. Just as on-device compute checks the power of the cloud on the personal level, distributed compute checks the power of the cloud on the societal level. This is not only the architecture of sovereignty, it's the architecture of stability. 6. Distributed compute enables a public digital infrastructure for AI. Think of what civilization relies on today. Public roads, public satellites, public radio spectrum, public utilities, public internet protocols. The next century will add public compute, public verification layers, public coordination mechanisms, public AI knowledge graphs. Distributed compute is the digital equivalent of public infrastructure, a system that no single institution can own, but everyone relies on. We've never needed this more. 7. The role of distributed compute is not to replace anything, but to enable everything. This is the key argument. On-device compute gives us autonomy, privacy, sovereignty. The cloud gives us power, scale, convenience. Distributed compute gives us neutrality, resilience, shared governance. None of these layers compete. All of them complement. Together they form the next logical architecture of intelligence. Local first, cloud optional, distributed guaranteed. The world after the cloud will not be one where the cloud disappears. It will be one where the cloud is no longer the single point of truth, and that changes everything. That's the end of chapter 8. Chapter 9. The hybrid future. Local intelligence plus encrypted cloud plus distributed networks. If the last chapters explored why each layer of compute matters, this chapter brings everything together into a coherent, future-proof architecture, one that balances power, privacy, performance, and resilience without collapsing into idealism or repeating the mistakes of the past. Because the future will not be purely local, purely cloud, purely decentralized, nor purely centralized. It will be hybrid. A 3-layer system where each layer does what it is best at, and no single layer becomes a point of failure, a point of control, or a point of capture. This is the architectural model humanity needs if AI is to remain safe, sovereign, and aligned with human freedom. So let's break it down. 1. The local layer, personal intelligence. This is the foundational layer, not because it replaces everything else, but because without it, everything else inherits the structural defects of centralization. The local layer gives privacy. Your data never leaves your device. Speed, zero latency inference. Autonomy, no platform dependency. Resilience, AI works offline in any scenario. Trustlessness, no faith required in external systems. This is the layer that protects your personal thoughts, your emotional processing, your creative work, your private queries, your sensitive planning, your identity, your life history. AI becomes yours, literally, computationally, architecturally. The local layer acts as your personal cognitive engine, but it cannot handle everything. Some tasks require scale, bandwidth, or collaboration, and this is where the next layer enters. 2. The encrypted cloud layer, optional, elastic, and transparent. Here's where nuance matters most. We're not throwing the cloud away, we're reframing it. The cloud is the optional layer, a powerful extension, not the foundation of intelligence. Its role is to provide large context workloads, document processing at scale, optional memory extensions, heavy multimodal tasks, high-resolution transformations, search over vast datasets, distributed training coordination. But with one massive shift, the cloud layer must become encrypted, opt-in, and transparent by default. This means you choose what leaves your device, you choose what stays local, you choose what is processed remotely, you choose what persists or is deleted. And importantly, the cloud cannot read your data, the cloud cannot train on your data, the cloud cannot infer your identity. This is a radical departure from how the cloud functions today. In the new model, the local layer handles personal inference. The cloud handles heavy compute without inheriting your private data. This eliminates the surveillance economies that defined the 2010 to 2020 era. But even with encryption, even with opt-in privacy, the cloud remains centralized, which means it remains vulnerable to political pressure, institutional capture, monopoly, outages, price shocks, single points of failure, which is why the third layer is unavoidable. 3. The distributed compute layer, the public backbone of intelligence. This is the layer that prevents monopoly, prevents institutional capture, ensures global resilience, enforces transparency, decentralizes power, makes compute a public good, provides neutrality, protects the architecture from future abuse. Think of it as the roads beneath the cloud, the satellites above the cloud, the internet protocols around the cloud, the public square of computation. This is not the blockchain hype era talking. This is a sober analysis of what's necessary to preserve openness in an AI-driven world. Distributed compute serves as a global coordination layer, an anti-censorship layer, a public verification layer, a transparent governance layer. It doesn't replace cloud or local. It blends them into a resilient ecosystem, where the cloud provides power and the local device provides privacy. The distributed network provides freedom from capture. 4. How these layers work together. The hybrid future works like a triangle of mutually reinforced strengths. We've got distributed compute. There's a diagram, again, you'll see it on the Substack. Distributed compute, local intelligence, and cloud intelligence. Let's walk through a real-world example. Scenario: you want to analyze thousands of documents to understand something complex. Your device handles the query, your private notes, your personal context, your identity, your emotional framing. The cloud handles the heavy lifting, large context processing, multimodal analysis, anything that exceeds local hardware. The distributed layer handles redundancy, permissionless access, neutrality, guarantee that no single cloud provider defines the behavior or allowed content, public verification of model weights, and update integrity. In this future, your device never exposes your private data. The cloud never sees unencrypted content. The distributed layer ensures no one can lock you out or manipulate outcomes. This is the architecture of cognitive freedom. 5. Why the hybrid model is inevitable. This is not speculation. It is driven by unavoidable forces. Hardware is accelerating. On-device AI becomes more powerful every year. Users want autonomy. Privacy and control are becoming mainstream concerns. Cloud costs are exploding. Centralized models are becoming too expensive to run. Governments are interfering more. Cloud providers face regulatory pressures, political influence, and censorship mandates. AI is becoming personal. When models know your inner life, locality matters. Failure in a centralized system is catastrophic. Outages take down entire industries. Distributed systems are maturing. We now have the tooling, protocols, and hardware to build them correctly. This hybrid world is not only likely, it is the only architecture that satisfies privacy, scale, and sovereignty simultaneously. 6. The hybrid future creates a new balance of power. Here's the most important outcome of all. The user becomes the center of the system again. For 20 years, the center of computing was the cloud. Before that, it was the server. Before that, it was the mainframe. The next era returns the center to the individual, but backed by public infrastructure and optional cloud extensions. It is a world where personal intelligence lives on your device. Collaborative intelligence lives in the cloud. Societal intelligence lives in distributed networks. Each layer reinforces the others. None can dominate alone. None can be captured. None can be abused without resistance. This is not utopian. This is architecture. An architecture, more than law or regulation or ethics frameworks, determines who holds power in the future. Chapter 10. Psychology, Agency, and Human Autonomy. Technology always reshapes society, but AI is the first technology that reshapes the self. The printing press changed how people access knowledge. The internet changed how people communicated. Social media changed how people expressed identity. But AI changes something deeper, how people think. This chapter is the emotional and psychological core of the essay, the part that explains why the architecture of intelligence is not merely technical, not merely political, not merely economic, but fundamentally human. Because when intelligence becomes a companion, a mirror, a collaborator, a confidant, the stakes transcend infrastructure. AI stops being a tool. AI starts becoming a context. AI begins to participate in consciousness. And where that intelligence lives, on device, in the cloud, in a distributed network, shapes the emotional, psychological, and existential experience of every human being who interacts with it. This is why sovereignty matters. This is why locality matters. This is why independence matters. So let's dive into the human layer. Number 1, privacy isn't about data, it's about dignity. People often frame privacy in technical terms: encryption, data retention, logs, permissions, metadata. But these are just mechanisms. Privacy at its core is about dignity, the ability to have a self that is not continuously observed, analyzed, or recorded. Humans need a place to think, a place to feel, a place to make mistakes, a place to express uncertainty, a place to rehearse ideas, a place to explore identity. Cloud-based AI intrudes on these spaces, not intentionally, but structurally. The simple act of sending your thoughts to a remote server, however secure, introduces a psychological tension. Who else could see this? Where does this go? What happens to me if someone misinterprets it? These are not technical fears, they are existential fears. On-device compute dissolves that tension. It restores the private interior. AI becomes not a confessional booth, but an extension of self. And this changes how people interact with it radically. 2. Humans think differently when they know they are observed. This is one of the oldest insights in psychology. Observation changes behavior. It increases inhibition, reduces vulnerability, distorts expression, suppresses emotional honesty, narrows the imagination, shifts identity performance, triggers self-censorship. When people talk to a cloud AI, they instinctively edit themselves, even if they trust the system, even if they think no one is watching. Their brain knows the truth. The message left the device. When people talk to an on-device AI, something different happens. They disclose more. They reflect deeper. They think more clearly. They explore darker, quieter fears. They engage emotionally. They ask the real questions. They become more themselves. Not because they've read a privacy policy, but because their nervous system recognizes safety. The distinction between cloud and local isn't just technical, it's neurological. 3. Agency requires independence. Humans feel in control when their tools obey them, when their data belongs to them. Their environment is predictable. Their identity isn't defined externally. Their decisions aren't coerced. Their thinking isn't shaped by invisible incentives. Cloud-based AI, even when benign, always carries the residue of dependency. Server uptime, API limits, moderation filters, capability restrictions, platform policies, business incentives. This dependence shapes behavior. When intelligence runs locally, the user becomes sovereign. The tool is genuinely theirs. The feedback loop is direct. The emotional relationship changes. The sense of agency strengthens. The system feels like a companion, not a gatekeeper. The psychological impact is profound. People think more freely when the machine is theirs. People express more openly when the machine is present. People learn more deeply when the machine is trustless. 4. Intelligence shapes identity. This is the part most people underestimate. AI doesn't merely answer questions. It influences worldview, reinforces belief, suggests emotional framing, colors memories, shapes decisions, trains behavior, affects self-perception, modifies values over time. When AI becomes ubiquitous, it becomes part of the identity formation process, especially for younger generations. And the question becomes, should the architecture shaping our identity be centralized? Should it belong to a single company? Should it be influenced by political winds? Should it be dependent on opaque moderation? When moderation algorithms become moral arbiters, when recommendation models become ideological filters, when AI systems reflect the biases of the institutions that build them, identity becomes infrastructure. Local first intelligence prevents this, not entirely, but structurally. It keeps identity formation closer to the individual. It decentralizes cultural influence. It reduces the algorithmic shaping of the self. Cloud AI cannot avoid influencing people. On-device AI cannot avoid reflecting them. Distributed AI ensures neither becomes a monopoly over consciousness. 5. Mental health depends on psychological safety. AI will become part of the mental health journey for millions, maybe billions of people, and the mental health domain is uniquely sensitive. People express their darkest fears, people share their traumas, confess their shame, articulate suicidal thoughts, seek comfort, clarity, stability. If these interactions happen in the cloud, users will self-censor. Institutions could intervene, governments could demand access, insurers could exploit behavioral data, employers could gain insights into emotional vulnerability, researchers could mine patterns, models could train on disclosures. Even if none of these things do happen, the possibility is enough to distort the behavior of the person seeking help. On-device mental health AI allows vulnerability, raw honesty, self-exploration, emotional regulation, unfiltered communication. Privacy isn't a feature, it's the precondition for healing. The architecture determines whether people feel safe enough to disclose what they actually feel. This is the human reason why locality matters. 6. Architecture shapes emotion. A cloud AI feels like a service. A distributed AI feels like a community. A local AI feels like a companion. This emotional framing matters because services are replaceable. Communities create identity. Companions become part of us. AI is trending towards companionship, not in a romanticized sense, but in the cognitive, collaborative, intellectual sense. We will think with our machines. We will remember with them. We will plan with them. We will create with them. We will regulate emotions with them. We will understand ourselves through them. If AI becomes a co-processor for the human mind, the architecture beneath it becomes the architecture of the self. This is the level where sovereignty stops being political and starts being existential. 7. The core thesis. When AI becomes part of thought, thought becomes part of infrastructure, and infrastructure determines freedom. Not ethics, not regulations, not corporate promises, not political frameworks, architecture. If intelligence lives on your device, you remain psychologically sovereign. If intelligence lives only in the cloud, you become psychologically dependent. If intelligence also lives in distributed networks, you become psychologically protected. This is what's at stake, and this is why the next chapter zooms out even further from the personal to the geopolitical. Have a quick breather. Hope you're doing well. Right. Chapter 11. The geopolitical. Chapter 11. The geopolitics of compute sovereignty. Every major technological shift eventually becomes geopolitical. The printing press destabilized monarchies. The railroads redrew borders. Electricity reshaped empires. Nuclear power rewired global alliances. The internet collapsed distance. But AI, and especially compute, is something different. AI is not a technology that nations use. AI is a technology that nations will be built on. Just as individual Just as industrial power once depended on coal, oil, steel, and manufacturing capacity, future national power will depend on compute, data integrity, and the sovereignty of digital infrastructure. In this chapter, we zoom out, far out, beyond the individual, beyond the cloud, beyond the company. We look at the global chessboard and what it means when intelligence becomes the core infrastructure of the 21st century power. Because the question of where AI runs, on device, in the cloud, in distributed systems, is not merely technical, it is geopolitical. 1. Compute is becoming the new strategic resource. Nations once competed for oil reserves, rare materials, trade routes, manufacturing supremacy. Today, they're competing for GPUs, semiconductor supply chains, AI talent, model weights, cloud infrastructure, training datasets. Compute is the new energy. Models are the new weapons. AI infrastructure is the new territory. This is not metaphorical. It's already visible. The US restricts chip exports to China. China builds domestic cloud giants. Europe demands digital sovereignty. The Middle East invests billions in AI clusters. Singapore positions itself as a global compute hub. Every nation understands the same thing. If you do not control your own AI infrastructure, you do not control your future. 2. The cloud creates strategic vulnerability. Most countries, including advanced democracies, rely on cloud infrastructure owned by American corporations, AWS, Google, Microsoft, Meta, Oracle. This is not inherently malicious, but it creates unavoidable risks. Geopolitical alignment risks, jurisdictional pressure, sanctions risks, policy being set outside national borders, surveillance exposure, leverage over domestic companies, concentration of economic power. If your country's digital infrastructure relies on a foreign cloud, that foreign nation indirectly influences your economy, your communications, your intelligence systems, your startups, your elections, your universities, your research pipeline, your AI readiness. It's not about trust, it's about dependency. 3. Nations want sovereign compute, but can't all build it. This is the uncomfortable geopolitical truth. Most nations cannot build their own cloud hyperscale, model training facilities, semiconductor fabrication plants, frontier GPU clusters, domestic LLM ecosystems. These require tens of billions in capital, decades of R&D, supply chain dominance, manufacturing capability, fast cooling and energy resources, specialized energy engineering talent, industrial scale infrastructure, which means only a handful of nations and corporations will have frontier-scale capabilities. And this creates a global AI hierarchy, strategic dependencies, technological colonization risks, asymmetric power dynamics, cascading vulnerabilities. This is where distributed compute enters the picture. Without naming anything specific, a public distributed layer offers a structural alternative to a world dominated by a few enormous AI superpowers. But hold that thought, we're not there yet. 4. The battle for AI is really a battle for infrastructure. Nations are beginning to understand that AI influence is not about who has the best model, who has the best research lab, who hires the best engineers. Those things matter, but they are downstream from the real determinant: who controls the compute infrastructure. Because the entity that controls the compute layer controls who gets access, how much it costs, who can be built, what can be built, what is censored, what is prioritized, which industries blossom, which industries die. Compute is the new policy lever. Compute is the new regulator. Compute is the new strategic bottleneck. This is why the US, China, EU, and Gulf states are frantically racing to build massive AI superclusters, subsidize GPU manufacturing, acquire chip designers, develop domestic cloud, secure supply chains, attract foundational model labs. They know this is their institutional revolution moment. 5. Centralization at a national level is still a centralization. Even if a nation fully controls its own cloud, the power is still centralized. The infrastructure is still chokeable. The intelligence is still controlled by the state. Censorship becomes trivial. Surveillance becomes inevitable. Political change becomes dangerous. State-level sovereignty does not automatically imply citizen-level sovereignty. One form of centralized power replaces another. The architecture matters more than the owner. A centralized national cloud is still a centralized cloud, which is why the future cannot rely solely on cloud sovereignty, state-run AI, centralized national superclusters, not if the goal is global stability and human freedom. 6. Distributed compute as a geopolitical stabilizer. So now we return to our architectural triangle. A distributed compute layer, owned by no single nation, influenced by no single corporation, is not just a technical innovation, it is a geopolitical necessity. It provides resilience to infrastructure collapse, resilience to authoritarian control, protection from corporate monopolies, insulation from political swings, neutrality in international conflicts, a global public good for innovation, a safety net for smaller nations, a balance against superpower dominance. Distributed compute is the modern equivalent of international waters, public internet protocols, neutral space, a global commons. Except instead of shipping lanes or radio frequencies, it protects the infrastructure of intelligence. 7. Multipolar AI stability requires hybrid architecture. A single superpower controlling AI infrastructure, unstable. A handful of corporations controlling AI infrastructure, unstable. A splintered world of national AI silos, unstable. But a 3-layer hybrid system, local compute, individual autonomy, encrypted cloud, industrial power, distributed compute, global stability, creates a multipolar equilibrium. It reduces systemic risks, political coercion, censorship control, single points of failure, arms race dynamics. It increases innovation, transparency, resilience, access, optionality, strategic stability. This is the architecture of peaceful competition, not runaway dominance. 8. The real battle of AI won't be won by models, but by architecture. Countries can copy models. They can tempt engineers. They can rebuild datasets, but they cannot easily copy distributed networks, global-grade hybrid architectures, edge compute ecosystems, trustless infrastructure models, decentralized governance, sovereign compute frameworks. These are multi-decade civilizational projects, and their value compounds. The architecture you advocate for isn't just technically superior, it's geopolitically essential. Because the world needs a future where intelligence is not monopolized, centralized, nationalized, politicized, or platformized. It needs a future where intelligence is local, optional, distributed, transparent, resilient, and fundamentally human first. And this chapter explains why. The next chapter explains how. So let's dive into it. Let me have a quick drink. Chapter 12. The architecture of the next era. Up to this point, we've explored the philosophical, psychological, and geopolitical forces shaping the future of intelligence. Now we bring all these threads together and define the actual architectural blueprint for the next era. A model that resolves the contradictions of centralization, empowers individuals, supports global scale, and remains resilient against institutional capture. This is not a speculative futurism. It's a practical, emerging framework shaped by a technological necessity, economic gravity, human psychology, national sovereignty, and the structural physics of compute. The winning architecture will not be the one with the most features, it will be the one with the fewest vulnerabilities. A world powered by AI needs an infrastructure that cannot be censored, shut down, monopolized, politically coerced, economically gated, or used to manipulate the cognitive fabric of society. The only way to achieve this is to treat AI as a monolith, but as a stack, an ecosystem where each layer solves what the others cannot. Let's build that stack from the ground up. Number 1. Layer 1, the on-device intelligence layer. The foundation, privacy, speed, self-determination. This is the bedrock of the new architecture, the part that touches the human directly. The device is the closest digital object to the self. It travels with you, it knows your patterns, it becomes an extension of your cognition. On-device intelligence handles private inference, personal memory, behavioral context, emotional nuance, user-specific adaptation, offline autonomy, real-time responsiveness. It is the personal layer of intelligence. This layer must require no trust, expose no data, rely on no server, degrade gracefully, be always available, work without network or permission. It preserves dignity, autonomy, and psychological freedom. It ensures that your personal mind lives on your hardware, but that is only the beginning. Layer 2, the privacy-preserving cloud layer. The optional layer, elasticity and scale without sacrificing privacy. This layer exists not for personal intelligence, but for heavy lifting, high context processing, large document analysis, complex multimodal workloads, computational expensive tasks, collaborative intelligence. Its purpose is not to replace the local layer, but to extend it. Crucially, this layer must evolve away from the surveillance economics of the 2010s and move towards a privacy-native paradigm. Fully encrypted processing, zero data retention, explicit user consent, transparent data flows, no training on user inputs, sandbox ephemeral sessions. The cloud should become a powerful tool, not a dependency, an accelerator, not an authority. By decoupling cloud compute from identity and surveillance, this layer is free to serve its technical purpose without inheriting the political risks of centralization. But even a privacy-preserving cloud remains centralized, making the architecture incomplete. That brings us to the final layer, layer 3, the distributed compute and governance layer. The collective layer, neutrality, resilience, public infrastructure. This is the structural innovation that anchors the hybrid model. It is the layer that prevents monopoly, guarantees global neutrality, resists political capture, provides public verifiability, restores a public commons for AI, and ensures intelligence remains a shared, not owned resource. Distributed compute in this context is not a buzzword or a branding exercise. It is a mathematically different way of organizing power. It provides redundancy across jurisdictions, resilience against single-point failure, transparent government mechanisms, participatory decision-making, global permissionless access, verifiable infrastructure integrity. This layer is the public layer, not controlled by a single corporation, not dependent on a single nation, not subject to the whims of political cycles. It acts as a stabilizing force, a counterweight to both personal autonomy, layer 1, and centralized efficiency, layer 2. In doing so, it creates a balanced ecosystem. The individual is sovereign, industry can scale, society remains resilient. This is the heart of our architectural sovereignty. 4. How the three layers interact. To understand why this architecture works, imagine a simple rule. Every workload should run at the lowest level that preserves autonomy without sacrificing capability. This means if something can run on device, it should. Personal queries, emotional processing, sensitive documents, conversational memory, private reasoning. This maximizes privacy and speed. If something requires scale, it moves to the optional cloud layer. Large PDFs, complex analysis, multi-gigabyte transforms, high-resolution multimodal prompts. But the cloud must never hold or infer private data. If something requires neutrality or resilience, it shifts to the distributed layer. Model verification, public knowledge graphs, compute marketplaces, safety evaluations, global coordination, governance frameworks. This ensures no single party can interfere. Each layer solves what the others cannot. Each prevents the others from becoming dominant. Each reinforces a multipolar balance of power. This is the architecture big tech cannot build, and it is the architecture governments cannot control. It is effectively a constitution of compute. 5. Why this architecture outperforms cloud-only or device-only models. Device-only models fail at large-scale inference, coordination redundancy, long context tasks, societal infrastructure, public safety mechanisms. Cloud-only models fail at privacy, sovereignty, psychological safety, censorship resistance, political independence, avoiding economic bottlenecks. Distributed-only models fail at personalization, latency, emotional intimacy, local autonomy, hardware optimization. But together, they create a system that inherits the strengths of all three and the weaknesses of none. A world built on this architecture would be private but scalable, local but collaborative, distributed but user-friendly, resilient but high performance, transparent but flexible. This is how we build an AI future that aligns with human values and modern realities. 6. This architecture is not a fantasy. It is an unfolding trajectory. We are already seeing model quantization breakthroughs, mobile GPU acceleration, encrypted inference prototypes, decentralized compute research, national pushes for sovereign AI, user backlash against centralization, cloud cost inflation, AI hardware in consumer devices, large open model ecosystems emerging. The hybrid model isn't a possibility, it's a trajectory. Every pressure, economic, cultural, political, psychological, is pushing us towards this three-layer stack. The industry just hasn't named it yet. When the world finally accepts this architecture, AI will shift from a platform-owned technology to a civilization-owned one. And that brings us to the practical question. How do we get from here to there? Let's just have a quick pause. Chapter 13, The Transition Ahead. We've outlined the architecture of a sovereign AI future, a hybrid world of on-device intelligence, encrypted cloud compute, and distributed neutral infrastructure. But architecture alone isn't enough. The real question is, how do we get from the world we have today to the world we actually need? Technological transitions don't happen because the correct architecture exists. They happen when the pressures of the present make the old models unsustainable. We are now entering that transition, slowly and suddenly. This chapter lays out the realistic multi-year path from today's cloud-dominated AI landscape to a balanced, sovereign, resilient ecosystem. It is not utopian, it is not instant. It unfolds in stages, each driven by structural forces that cannot be reversed. We'll explore the pressures forcing change, the emerging capabilities enabling change, the transitional hybrid models, the early failures and course corrections, the role of institutions, the role of individuals, the long arc of sovereignty. Okay, let's begin. Pressure 1. The economics of cloud AI becoming unsustainable. Cloud AI is experiencing a collision between demand and cost. The cloud was built for storage, APIs, static web apps, collaboration tools. It was not built for billions of users running inference-heavy models daily. As usage scales, cloud providers face spiraling GPU costs, unprecedented energy demand, data center expansion limits, brittle supply chains, massive capital expenditure, unscalable operating margins. This leads to price increases, usage caps, restrictions on model access, differential capability tiers, prioritization of enterprise clients. The cloud is creaking under AI's weight. This economic reality accelerates the transition to on-device compute, not because it's philosophically better, though it is, but because it's financially inevitable. Pressure 2. Users reject surveillance economics. In the past decade, people tolerated and often ignored surveillance because the trade-off was convenience. They didn't understand the implications. The data was just behavioral. AI changes this entirely. Users now realize their thoughts are being processed. Their queries are deeply personal. Their conversations are intimate. Their emotional states are inferable. Their vulnerabilities are exposed. This triggers a psychological revolt. The 2020s will be remembered as the decade when average users began to understand the cost of centralized intelligence and demanded alternatives. On-device compute is no longer niche, it's becoming expected. Pressure 3. Nations demand sovereign compute. As established in Chapter 11, no country wants to rely entirely on foreign clouds for military intelligence, economic forecasting, domestic AI regulation, national datasets, healthcare systems, educational infrastructure. Nation-states are pushing aggressively towards domestic clouds, sovereign LLMs, restricted chip exports, regional compute alliances. This reconfigures the global landscape. When nations invest in sovereign AI, the private sector follows. The ecosystem shifts, the incentives evolve, and distributed systems aligned with sovereignty rather than centralization become strategically attractive. Pressure 4. Hardware advances make local intelligence inevitable. Every year, local VRAM increases. Neural accelerators improve. Quantization becomes more efficient. Models become smaller and smarter. Edge devices get cheaper. Inference frameworks become lighter. We are 2 to 3 years away from 50 to 70 billion parameter models on a consumer hardware, real-time multimodal inference on laptops, persistent local memory with encryption, Whisper-like audio models embedded at OS level. Local AI for offline societies. AI that fits in your pocket with frontier adjacent capabilities. When hardware shifts, ecosystems shift. The cloud dominated the 2010s because devices were weak. On-device AI will dominate the 2030s because devices will be strong. 5. Stage 1 of the transition, hybrid local AI. This is where we are today. AI feels local, but it's actually partly cached, partly centralized, partly opaque, partly dependent on servers. Apps that claim local mode often still use cloud fallback, store embeddings remotely, phone home for analytics, rely on server-side moderation, fetch remote updates silently. This is the messy middle, but it's unavoidable because transitions always begin with hybrids. In this stage, users begin demanding real local-first behavior. Developers begin exploring device-native inference. OS vendors integrate AI accelerators deeply. Cloud-first companies start feeling pressure to evolve. We're still in the early innings. Stage 2. Local primary, cloud optional. This is the next decade. In this stage, personal intelligence runs entirely on device. Cloud is used only when necessary. Privacy becomes the default expectation. Hardware becomes the new moat. Users begin comparing apps based on autonomy. Companies differentiate based on sovereignty guarantees. Most AI apps will be local by default, cloud by exception. The behavior flips. This is when the psychological shift becomes permanent. People begin trusting their device again. AI begins feeling personal again, and developers who fail to adapt will disappear. Stage 3. Distributed compute goes mainstream. Once the world stabilizes around local first plus optional cloud, a new need emerges. Neutral shared compute that cannot be captured. Distributed compute becomes a public utility, a global commons, a safety layer, a governance mechanism, a political stabilizer, a resilience network. This is when the architecture triangle completes. Distributed compute, on-device, and encrypted cloud. This isn't a sudden revolution, it's a gradual absorption of functionality. Verification of model weights, global shared compute workloads, public safety evaluations, collaborative training datasets, decentralized coordination structures. It becomes the backbone of the digital world, just like DNS, TCP, IP, and public key infrastructure. Stage 4. The cloud shrinks but strengthens. Counterintuitively, when the cloud stops being the center of everything, cloud becomes better. Cloud providers shift from surveillance to computation, ownership to interoperability, identity mining to infrastructure services, lock-in to open protocols, data hoarding to encrypted workflows, platform dominance to global collaboration. Cloud doesn't die, it matures. It becomes one layer among many, powerful, essential, but no longer sovereign over intelligence. Stage 5. AI becomes personal, not platform-owned. This is the part nobody is ready for, but everyone will experience. Your AI will become more personal, contextual, generational, portable, persistent. It will know you intimately, not as a dataset, but as a companion. Your AI will travel between devices, be recoverable and exportable, be independent of any single provider, contain encrypted memory only you can unlock, adapt to your emotional history, become an extension of your selfhood. This only becomes possible when the local layer is sovereign, the cloud layer is optional, the distributed layer is neutral. The transition isn't just technical, it's psychological, cultural, political, and civilizational. Stage 6. Intelligence becomes a public good. The final stage, the steady state equilibrium, is a world where AI is treated not as a product, but as infrastructure, just like water, electricity, the internet, public roads, open radio spectrum. Intelligence becomes accessible, decentralized, resilient, anti-fragile, verifiable, democratized. The global architecture stabilizes into personal compute for individual sovereignty, encrypted cloud, industrial capability, distributed compute, systemic resilience. This is not science fiction. This is the only equilibrium that avoids monopoly, surveillance, political capture, algorithmic oppression, infrastructural fragility, cognitive dependency. It is the only architecture compatible with human freedom in an AI-driven world. 11. The transition will be messy, but it will be worth it. People often imagine technology transitions as neat curves. They're not. They're chaotic. There will be resistance, lobbying, regulatory pressures, misinformation, political interference, cloud incumbents protecting their moat, false decentralization attempts, snake-oil privacy claims, hybrid models pretending to be local, nationalistic AI fragmentation. But underneath the chaos, the direction is clear. The forces driving the transition are too fundamental, too structural, too economic, too psychological, too political, too human to be stopped. And that brings us to the end, the final chapter. Not a summary, not a conclusion, a reflection, a reminder of what this is really about. So before I dive into chapter 14, my final reflections, I'll have a quick drink. So apologies for a few of the ums and ahs, and my eyes sometimes go a bit funny when I'm sort of reading as well. Right, okay, chapter 14, we're almost there. Final reflections. Intelligence should belong to people. There is a moment in every technological era when the conversations shift from what we can build to why we should build it. AI has reached that moment. For decades, technology was primarily about efficiency, convenience, speed, capability. We spent years obsessing over performance benchmarks, user interfaces, cloud architectures, GPUs, and features. But AI is different. AI forces us to confront a deeper question. Who should intelligence belong to? Not just the intelligence in a phone or a laptop, not just the intelligence in the data center, but the intelligence that increasingly participates in our thoughts, learns our preferences, shapes our ideas, influences our emotions, and helps us navigate the world. The answer used to be implicit. Intelligence belonged to whoever built the model, owned the servers, controlled the trainer pipeline, or wrote the API. But that answer belongs to the past. We're entering a new era, one where intelligence becomes a universal substrate of human life. In that world, the idea that intelligence should be owned by a handful of corporations or states is not only wrong, it is dangerous. Intelligence should be accessible. Intelligence should be private. Intelligence should be resilient. Intelligence should be free from coercion. Intelligence should be a public good. Intelligence should be aligned with the individual, not the institution. Intelligence should ultimately belong to people. This essay has taken a long road to that conclusion. Through the history of cloud computing, the return of on-device intelligence, the limitations of hardware, the psychology of privacy, the geopolitics of compute, and the architecture of sovereign future. But the through line is simple and unavoidable. The architecture underneath the AI the architecture underneath AI will determine the freedom above it. If intelligence runs only on the cloud, then intelligence is owned by whoever owns the cloud. If intelligence runs only on national infrastructure, then intelligence becomes a geopolitical weapon. If intelligence runs only on device, then society becomes fragmented and fragile. If intelligence runs only on distributed systems, then individuals lose the intimacy they need for personal growth. But when intelligence runs locally for the intimate and personal, an encrypted cloud for the heavy and collaborative, across distributed networks for the neutral and resilient, we get something we've never had before. An architecture where power balances itself. A world where individuals own their cognition, societies own their infrastructure. No single institution owns the future. This is not idealism. This is engineering. This is architecture. This is sovereignty redefined for the age of intelligence. And it's not only possible, it's already beginning. At the center of all this, the cloud, the devices, the geopolitics, the distributed nets, is a simple truth. Humans want to feel safe in their own minds. That's it. Everything else is commentary. People want a space where their thoughts are not monitored. People want tools that do not judge them. People want intelligence that doesn't require trust. People want autonomy without isolation. People want capability without surveillance. People want power without dependency. People want technology that amplifies them not extracts from them. And that desire is the most powerful force in the entire AI revolution, the instinct for sovereignty. This instinct is not political, it's not ideological, it is human. When people realize they can carry their intelligence with them, encrypted, local, private, untouchable, they won't want to go back. When nations realize they can build on neutral, resilient infrastructure, they won't want to rely on monopolies. When developers realize they can innovate without central choke points, they won't want old architecture. When companies realize the economics of local first AI outperforms cloud independence, they will pivot. When society realizes that intelligence can be a public good, the architecture of civilization will change. This is the future we are building towards, not because it is trendy, not because it's ideological, but because it is inevitable. The pendulum of compute always swings towards equilibrium. And for the first time since the dawn of the cloud era, equilibrium is within reach. My final thoughts. The next era of AI will not be defined by who builds the smartest models, but by who builds the most sovereign architecture. Because in the end, intelligence should belong to people, not platforms, not governments, not institutions, people. That is the future worth building. Wow, got to the end in one take. That was a challenge. I'm not sure how long that's taken, but if you're still here, I really appreciate it. Thank you so much. Lots to think about. Lots for me still to think about and write, and I've got some more essays in the pipeline. But yeah, thank you for joining us on this journey. The essays, the philosophy, and the push towards sovereign AI. I think that's incredibly important. Subscribe to the channel if you haven't done so already, and share this video with whoever else you think might be who might benefit. But I really appreciate if you're still here, and yeah, let's join us on this journey. Brilliant. Take care for now, guys.